Hey guys, so here's the notes for 3.3. We're going to be talking about factoring difference of squares. So what could difference of squares look like? Well, this is where we're going to have our ax squared, and then we're going to have our minus c. So that means we are going to have a binomial. So remember that means two terms, okay? So there is no x term, no middle, okay? Now what's going to happen is that our a and c values are going to be perfect squares. And when we factor these, we will always have subtraction. Okay. So these are really, if you think about it, the terms that you have to meet in order to be a difference of squares. So to be a difference of squares, it has to be a binomial. You have to be subtracting. So if you see a plus c, that is not a difference of squares and you can't factor it. And your a and c values have to be perfect squares. Well, then let's go ahead and talk about our perfect squares. Maybe this will help us out. Let's go ahead, let's list the perfect squares from 1 to 250. I want you guys to go ahead and do that on your own. Okay, let's see what you said for the perfect squares. So the first one is actually 1. Hopefully you said that. Then we have 4, then it's 9, so that's 3 squared. Then we have 4 squared, which is 16. 5 squared is 25. And we get 36, 49. 8 times 8 gives us 64, 81. 10 times 10 gives us 100. Now 11 squared is 121. 12 squared is 144. 13 squared is 169. Then we have 14 squared. That's going to be 196. So you just switch that. 15 squared is going to be 225. And that's probably the highest you need to go because 16 squared gets a little bit big there. Okay? So these are your perfect squares. Now you might be wondering, how do I know these are my perfect squares? And do I need to memorize this list? No, you don't need to memorize the list. All you have to do is take a number and square it. And that gives you your perfect square. So like if you take 2 squared, what does that give you? 4. And what do I mean by squared? Like this. 2 squared, it gives us 4. So 4 is that perfect square. If I do 3 squared, that gives me 9. That is a perfect square, the number 9. Okay? Whoops, I was going to say cubes. We should be saying squares. Yeah, okay? So you don't even need to memorize the list. All you need to do is know how to generate the list. Take a number, square it, and whatever number you get, that is your perfect square. Okay? Okay, let's go ahead and try some of these then. Okay, here are our examples. So let's start with x squared minus 4. Now notice with x squared minus 4, 1, it is a binomial. There are 2 terms. 2, it is subtracting. And our a and c values, they are perfect squares. Now notice the a value, or the number in front of x squared, is 1. 1 is a perfect square, okay? So how we're going to factor this is really simple. So we create, of course, our 2 sets of parentheses, so 2 binomials. Now, if your a value is 1, like we did before in our very first section, when we factored when a was equal 1, you just do x and x, okay? Then with the 4, we are going to square root it, okay? So meaning, what would be the square root of 4? That would give me 2. Now let's talk about the signs. In order for us to eliminate the middle part, or the x term, one of the parentheses needs to be a minus, the other one has to be a plus. Because what happens is when we do negative 2x plus a 2x, those terms cancel out and we're not left with that middle term, okay? Now it doesn't matter the order, so you could do x plus 2 and then x minus 2 or vice versa. So this would be our final answer. And I kind of want to show you with that multiplication what that does look like. So we get x squared plus 2x minus 2x minus 4. Notice here we have plus 2x minus 2x. They cancel. So that's why we have to have a plus and minus, because we cancel out that middle term. So here's our final factorization here. Okay, let's try x squared minus 36. Okay, so we create our two sets of parentheses, because notice our a value is 1 on the x squared, so I just do x and x. This is a binomial. We are subtracting, and we know that our a and our c values are perfect squares. So now we just take the square root of 36. That's going to give us 6. And we have one addition, one subtraction. And that's all you got to do. Okay, go ahead and pause the video and try the next problem. Okay, we create our two sets of parentheses. We do know that this is a square or difference of squares because we have a binomial. We are subtracting, and our a and c values, they are perfect squares. So because our a value is 1, I just do x and x. So with 64, I take the square root of it. That gives me 8. And one set of parentheses needs to be a plus, the other one needs to be a minus, and that is it. Okay, I would like you guys to go ahead, pause the video, and just try x squared minus 144. Go ahead and factor that. Okay, here our a value once again is 1, so I do x and x. We do know this is a perfect or difference of squares because we have binomial subtraction and our a and c values are perfect squares. Square root of 144 is 12. We got 1 plus, 1 minus. Now let's look at the next one. We have 9x squared minus 64. Now notice our a value is not 1. It's another number. Now we will still treat this like we usually do. But going back to when we did our 3.2 notes, remember, anytime your a value is not 1, you first have to ask yourself, do the terms have anything in common that we can take out? So we still really have to ask ourselves about that. So with 9x squared minus 64, this is a difference of squares. Because we know that both 9 and 64, they're perfect squares. We have subtraction, and it's a binomial. Now, before I factor, I do need to see, do these two terms have anything in common that I can take out? No, they don't have a number in common, and they don't have a variable in common. So I just factor like I usually do with difference of squares. Now, what you have to do is, instead of just putting x and x, we need to take the square root of 9. Well, what's the square root of 9? 3. So I have to have 3x and 3x. What's the square root of 64? We know that's 8 and 8. And one of them's a minus, the other one's a plus. And that's our final answer. Okay, let's try 49x squared minus 1. So first, do these two terms have anything in common that we can take out? No, they don't have a number, nor they have a variable, okay? So now, we just basically do the same thing as we did the last time. We create two sets of parentheses. And we know this is a difference of squares because it's a binomial. We're subtracting, and 49 and 1, they're perfect squares. Well, what's the square root of 49? 7. So I have to do 7x and 7x. And then what's the square root of 1? 1. Okay? So I have a 1 minus and a plus, and then that's my final answer there. Okay, let's try some more examples here. Okay, so we have 36x squared minus 9. So we have to see, do these two terms have anything in common? Actually, they do. They both have a 9 in common. Hopefully you guys recognize that. So we first actually have to take a 9 out and rewrite this. What is 36 divided by 9? That's 4, and we're left with x squared. What is 9 divided by 9? 1. Okay, now let's see if we can factor 4x squared minus 1. Well, it is a binomial, we're subtracting, and 4 and 1 are perfect squares. So this is still a difference of squares. Now I do need to bring down my 9, that does not go away, and I create my two sets of parentheses. Okay, square root of 4 is 2, so I have a 2x and 2x. Square root of 1 is 1, and then 1 needs to be minus, 1 needs to be plus. Okay, what I'd like you to do is go and pause the video and try the next two on your own. Okay, let's see what you got. So for the 169x squared minus 121, do they have anything in common? Actually, they do not. Okay, so we can't take anything out. So we just do our two sets of parentheses, and we know this is a difference of squares because it's a binomial, they're subtracting, and 169 and 121 are perfect squares. Well, what's the square root of 169? It's 13. So I have 13x, 13x, And then square root of 121 is 11. So I have 11 and 11, 1 minus, 1 plus. There we go. Okay, the next one, do these two terms have anything in common we can take out? Yes, they actually have a 2 in common, so I got to take that out first. Well, 2 divided by 2 just leaves me x squared, and negative 18 divided by 2 gives me 9. If we did not take that 2 out, then you would have thought, oh, this is non-factorable. I can't do anything here. Okay, so be careful. Always make sure when the a value is not 1, you got to check if they have anything in common that you can take out. Okay, now we can go ahead. X squared minus 9, that's the difference of squares. So I break down my 2, do 2 sets of parentheses. I do x and x. I take the square root of 9, so I have 3 and 3, 1 minus, 1 plus. And there's my factorization there. Okay. I would like you guys to go and pause the video and try these last 3 here. Okay, let's look at the first one. 5x squared minus 125. They do have a 5 in common, so I got to take that out first. 5 divided by 5 gives me x squared minus 125 divided by 5 gives me 25. Okay, bring down the 5, 2 sets of parentheses. Okay, x squared minus 25 is a difference of squares. I do x and x. Square root of 25 is 5. I have 1 plus, 1 minus, and this is my final factorization here. Okay, 20x squared minus 45. They both have a 5 in common, so I take that out first. Okay, 4x squared minus 9 is a difference of squares because it's a binomial, subtracting, and 4 and 9 are perfect squares. Bring down the 5, create your 2 sets of parentheses. Square root of 4 is 2, and square root of 9 is 3. 1 minus, 1 plus. And our last one, they actually do have something in common. They actually have a 6 in common here. So I'm left with 25x squared minus 36. Okay, 25x squared minus 36 is a difference of squares. It's a binomial, subtracting, and 25, 36 are perfect squares. Square root of 25 is 5. Square root of 36 is 6. 1 minus, 1 plus. There's my final answer. Okay, make sure you guys work on the homework assignment, and if you have any questions, make sure you contact me. I'll see you guys later.